Okay, guys, I wanted to show you how to explain the A quiz on this video, and I've already talked about how the grams to moles, you're dividing by their molar masses on question 1, and a lot of you guys had that right. The order was B, then C, then A. A lot of you guys ignored putting it in order. But the idea is that you're going to be doing some grams to moles or moles to grams. You divide by molar mass to go to the mole, or you multiply by molar mass if you have moles to grams. So in this particular example, you guys did really pretty well on getting the moles. A lot of you guys ignored that oxygen is 32, not 16. When they're elemental in these kind of problems, you will use diatomic oxygen. When you come down to the empirical formula, like in the hydrogen example, you only use 1. When it's in the compound for empirical formula, use 1. But when you're talking about them as an actual substance totally by itself, you're going to make it diatomic. Okay, so let's go on to the empirical formula. That's where we were at in that last video, and you guys had a 3.2 to a 7.2 ratio. You divide the bigger by the smaller, and you're going to get 2.25 for hydrogen to 1 carbon. So you got to make them whole. So you have to times them both by 4 to get C4H9. That is your lowest ratio. How you get the bigger ratio is that you're going to take, you're going to calculate, sorry about moving so quickly, but if you go take a minute here to go from empirical to molecular, you're going to calculate the molar mass of the empirical. Okay, get that number. That's always going to be a smaller number. You're going to take the given mass that's in the problem, divide it by the molar mass of the empirical. Okay, so for the A quiz with C4H9, you're going to take 48, that's 48, plus 9 to get 57. How many 57s go into the number given in the problem? In the problem, it was, flip over to that, we move the paper here, you had 114. 114, so when you add up the molar mass of C4H9, it's going to be 57. So how many 57s go into 114? You're going to times that by 2x, 2 times. So C4H9 times 2 is C4H18. C8, that's supposed to be an 8, 18. So it's supposed to go from C4H18 to C8H18. So the process is that you always add up the molar mass of the empirical. Empirical is C4H9. So you add that up, and that's where I got the 57. And you take 114 over 57, and you get 2x. Then you take 2 times the empirical to get the bigger molecular C4H18. Okay? Now, the next problem was on percent composition. A lot of you guys simply got that correctly. That's 84, listen to me, 84% to 16%. But a lot of you guys, and you use these numbers up here, which is great. The 38.4 divided by 45.6, and the 7.2 divided by 45.6. Whenever you do percent composition, you're always going to take, let me look at the equation here, you're always going to take the mass of the element over the mass of the total compound. Okay, and in the problem that you had, those numbers were given right here at the beginning of question 2, so you could use those numbers down here on C. Again, a lot of you guys had this correct, and you followed it right, and you got 38.4 divided by 45.6, and you had 7.2 divided by 45.6. So that really wasn't a problem. It was more of showing the work. That was the issue. Okay? So let's go on. The next question was about empirical formulas. Okay? So empirical formulas, let's look at what I have here. The formulas of lowest ratio are empirical. The formulas of lowest ratio are empirical. So if you look at all these examples, these two you can break down and reduce the 2 and the 2 and the 2 and the 6. so they're not empirical. But the other 4 you can't reduce down. You can't cut 2 and 1 down, or 2 and 5, or, oh, I messed up here, 2 and 6. So we got to cross that out there. That's not empirical. I didn't realize I did that when I wrote that out. That's not empirical, okay? But the other 3 are, I think it was C3H8, that's empirical, okay? These can be reduced down. These can be reduced down. They cannot be reduced down, but these can. So when they can be reduced down, they're not empirical, but when they are not able to be reduced down, then they are empirical. The lowest ratio are empirical. The lowest ratio are empirical. Okay? Now, let's go on to our next question, which was the hydrate question. And so many of you guys had this right. Hydrates have water integrated in the crystals, and hydrates do not. And the hydrated have more mass than the dry crystals. So I think pretty much all you guys had that pretty well correct on number 5A. That really wasn't an issue. It was more of talking about the bottom part of the question, and I want to go ahead and set it up on my white paper. It's a little bit clear, okay? And on the actual A quiz, we had these 2 numbers given in the table: the moles of water and the moles of dry. And since they're already there and they're already moles, then you always take the moles of the water over the moles of the anhydrous. That's all that you had to have done. So you're going to do 0.160 divided by 0.08 to give you 2x. And that would have been the answer for calcium sulfate dihydrate. Now, let me warn you, on your quiz Monday, I'm going to set it up where you have to do the mass to moles first. You're going to take the mass of anhydrous, not the hydrate one, the dry form only, divided by its molar mass to get to moles. Then you're going to take the mass of water and divide it by its molar mass at 18 to get to moles. And then once you have the 2 mole numbers, you should see that the water's higher than the anhydrous, and that should give you a whole number. Okay? Let me warn you that you will take mass to moles on the quiz Monday. It's going to be a little bit longer question. On your question, the way the table was set up, let me move the paper over to that. I actually have the moles listed. So you simply had to do the ratio to get to 2x to get to the answer for calcium sulfate dihydrate. Again, please get a hold of me, contact me if you're having any questions or problems on Remind or on regular email, and I'd love to help you this weekend.